All right. And it's a very, very important subject. It's a very, very important subject in the world of mathematics, especially when you're talking about your JAM, your WAEC, your NECO, and the likes. Partial fractions are very, very important. So I want you to pay keen attention to it. Now write this down. A fraction. A fraction A fraction is a symbol. A fraction is a symbol indicating the division. Is a symbol indicating the division. Indicating the division of integers. 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 Indicating the division of integers. Full stop. E.g., 13 divided by 9. 13 divided by 9, comma. 2 over 3. 2 over 3, comma. Are fractions. Are fractions and are called common fractions. And are called common fractions. The dividend, that is full stop, and are called common fractions, full stop. The dividend, dividend, D-I-V-I-D-E-N-D. The dividend is called the numerator. The dividend is called the numerator, and the divisor is called the denominator. And the divisor is called the denominator. To express a single fraction. To express a single fraction into sum of 2. To express a single fraction into sum of 2 or more fractions. Into sum of 2, S-U-M. Into sum of 2 or more single fractions. Sum of 2 or more single fractions. Sum of 2, S-U-M, of 2 or more single fractions. Is called partial fraction resolution. It's called partial fraction resolution. It's called partial fraction resolution. Have you taken that? Have you taken that?
Yes, sir.
All right. Example. Now, example. All right. Let's. The whole idea of partial fraction is splitting a complex fraction into different single fractions. Splitting down a fraction. Like we have the first fraction, since we know that it is not solvable. Since we know it is not solvable, so what we do is we split it down into solvable fractions. Are we together? Are we together? All right, so let's look at this example. Example 2x plus x squared minus 1 divided by x multiplied by x squared minus 1 is equal to 1 over x plus 1 over x minus 1 minus 1 over x plus 1. Now, look up. Look up. I'm going to teach us how to break down this guy here into these guys. Are you together? Now, when this guy is broken down into this, you can easily solve it. Yes, sir. Now, you refer to this one as the resultant fraction of this fraction. This is the resultant fraction of this fraction. When they give you an expression, have you written this? Yes, sir. All right. All right. An expression of the form. An expression of the form. An expression of the form P of x equal to a naught x to power n All right. P of x. This is the general definition of a polynomial. This is the general definition of a polynomial. And I want to connect it to the partial fraction I want to teach you. Is that okay? Now, you already know what the polynomial is from the last class. Is that not so? Yes. P of x is the polynomial equal to a naught x to power n plus a n minus 1 x to power n minus 1 up to a2 x2 plus a1 x1 plus a naught x naught. Are we together? This is xn. As n is decreasing, look at n is decreasing. You have to power n minus 1, to power n minus 3, n minus 4, up to power 2, to power 1. That is for the degrees of x, up to power 0. X to power 0 is 1. So you have a naught times x to power 0, which is what? 1. So it's decreasing. It's just like you have 4x cubed plus 3x squared plus 2x plus 1. So the degrees are declining. Is that okay? So that is just what this general definition is talking about. The declining of those polynomial, of those degrees. Is that okay? All right. Yes, go ahead, please. Is that what? Where is G? All right. This is A. Where is G? Okay. Oh. You thought I wrote something like this? Oh, this is G. This is A. It's listen, it's in alphabet. You want to show me that you know. Small 1 plus 1, you don't know. It's how to write A that nursery 1 and pre-nursery kindergarten children know how to write. That is your problem. Sorry. Look at you. Look at you that is abusing this thing. You are even raising shoulder. It's A you are fighting with. Sorry for you. All right. So as I covered it now, your mouth will also be covered.
Is it A1? AN1 or ANY?
Where? All right. Write this down again. Processes. A proper fraction a proper fraction nx over dx can be resolved into partial fractions. By the following processes. If the denominator
yes, obviously.
I, if the denominator d of x if the denominator d of x, that d of x, this guy here, if the denominator d of x,
Right on.
if in the denominator d of x a linear factor ax plus b, a linear factor ax plus b exists 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 and is non-repeating and is non-repeating non-repeating and is non-repeating and is non-repeating and is non-repeating, comma, its partial fraction its partial fraction its partial fraction will be of the form 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 a all over ax plus b, where a is a constant where a is a constant whose value is to be determined. What this means is, for instance, look up. This is what I means. When you are given a fraction, when you are given a proper fraction, and the partial fraction is to be determined, if the denominator is of a linear function or a linear map. I already told you what a linear function is, right?
Yes, sir.
Good. Now, if the denominator is a linear function, this is how it will be represented. For instance, don't write this. I just want to illustrate I for you first. If you have 2, let's say for instance you have 2 divided by x into x plus 1, or let me say 2x plus 1. Are we together? Assuming you have this kind of a fraction, it is required, it's not clear? Whereas the I is saying that if you have a fraction of this format, a proper fraction of this form, whereby I told you that the highest degree of a linear function is what? The highest degree of a linear function is what? 1. So any function you have that is of degree 1 is called a linear function or a linear map. So we said if you are having a linear function in the denominator, 2x plus 1 is a linear function, right? It's of the form ax plus b, where in this case your a is 2 and your b is what? 1. If it's x plus 1 I have, if it's x plus 1 I have, my a here is 1, my b is what? 2. So this is of this format. So they are now saying that if you are having this kind of case, how you resolve it is going to be a all over x plus b all over x plus 1. Are we together? All right. I. If the denominator, sorry, if in the denominator dx, if in the denominator, that is I. If in the denominator d of x, a linear factor, this guy, a linear factor ax plus b occurs n times, occurs n times, occurs n times. That is IE. AX plus B to power n. AX plus B to power n. If it occurs n times, i.e. AX plus B to power n, comma. Yes, go ahead. I should restart. I should repeat myself. But I've never repeated class all my life. So why should I repeat myself? Is that what? What happens for me now? I've never repeated class all my life. He said, okay, I should rephrase myself. Okay, rephrase myself. Okay, the English. I should come again. Come again. I should come again. All right. All right. If in the denominator d of x, a linear factor ax plus b occurs n times, occurs n times, n as in Noah, n times, i.e. ax plus b to power n, ax plus b, that is in brackets, to power n. Then there will be n partial fractions. Then there will be n partial fractions of the form. Then there will be n partial fractions of the form. There will be n partial fractions of the form. Of the form a1 all over ax plus b plus a2 ax plus b squared plus an where a1 a2 up to an are to be determined. Are to be determined. I.
That's the question.
Go ahead.
That's the first well, when the denominator is in linear
Function.
function.
Uh,
If you have like now you have x into x plus 1. You have x plus 1 into x plus 1. Will it be a over
yes.
x plus 1?
Beautiful. Your head is coming in. It's coming home. Your head is returning. Receive grace for your head to return. Okay, Emperor. Are we together? Now let's run with Bugatti now. Okay. Okay, someone is asking, why did I put plus dot dot dot? The three dot means there are plenty other A over this. There are plenty of them inside. So this dot 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 is to shorten. You get it right? All right. I. If in the denominator, yes. If in the denominator d of x, a quadratic factor, a quadratic factor ax squared plus bx plus c exists and is non-repeating. Exists and is non-repeating. Exists and is non-repeating. I'll send you out very soon. Exists and is non-repeating. Yes. Huh? I didn't hear you. Okay, say it again. All right. If in the denominator d of x, a quadratic, if in the denominator d of x, look at the d. If in the denominator d of x, a quadratic factor ax squared plus bx plus c, this is d of x, exists and is non-repeating. A quadratic factor ax squared plus bx plus c exists and is non-repeating. Its partial fraction will be of the form. Its partial fraction will be of the form ax plus b all over ax squared plus bx plus c, where a and b are constants to be determined. You say what? You are? You're not seeing. Come and sit down here. Yes, sir. I said that. So sit down where you are. Yeah? You be like I don't get in there. IV. If in the denominator d of x, if in the denominator d of x, a quadratic factor, if in the denominator d of x on the board, if in the denominator d of x, a quadratic factor ax squared plus bx plus c, ax squared plus bx plus c occurs n times, if in the denominator d of x, a quadratic factor ax squared, plus bx plus c occurs n times, that is i.e. ax squared plus bx plus c, this occurs n times. This guy here occurs n times. Then there will be n partial fractions of the form. There will be n partial fractions of the form. There will be n partial fractions of the form. There will be n partial fractions of the form. There will be n partial fractions of the form. A1x plus B1 plus A2x plus B2 plus ANX plus BN where A1 and are constants to be determined. So quickly, your break is what time? 11. Okay, 11 o'clock to 11:15, right? Good. Before you go your break, write this quickly and then we'll solve some beautiful examples.
What were you writing?
All right, example. We are in serious business here,
Yes, sir.
and we must make profit.
Amen. Amen. Profit of how much?
Profit of X and Y. Let's look at some examples. Resolve 7x minus 25 into partial fractions.
I don't like that. Let's make say what? You have money, man. Can you come and take it? I feel like it's coming.
All right. Who can help us with what is on the board? Who can help us with this? The first thing we said is the first thing you look at in partial fractions quickly. So when you are given a fraction
Yes, sir.
and you have to resolve into partial fractions, the first thing you look at the denominator. What is the form of the denominator? Is the denominator linear? Is it quadratic? Is it a polynomial expression? So you first of all identify the form. You first of all identify the form of the denominator. Now, for what we are having here, what is the form of the denominator?
It's a linear, sir.
What is the form of this denominator?
It's a linear denominator, sir.